All right, so this week we're talking about joins. And joins, and I just said this, they're probably one of my favorite things. And I think it's because like really that's what makes a database special. I'm sure we've all used Excel in a way where we've done, if you've ever done like an X lookup function in Excel, essentially we're going to do the same thing. Where basically we want to like kind of match some columns together, but we're going to do it between tables, which is kind of what makes databases so special. I think is relational databases is because we can kind of meld this data together. And if you've been on the teams, you'll notice that there's already been some questions. But basically, I want to start from the beginning. I hope you've watched the videos in the announcements. But regardless, I kind of want to just start from the beginning, make sure we understand everything. So that way it kind of makes some sense. So anyways, let's just start with some basic ones. So as we've all seen, hopefully by now, given that it's week 4, is that a lot of our tables, we never have like the complete picture. So like, for example, if we take a look at customers, select everything from customer, make sure we use Sequila up here. So if we select everything from customer, we'll notice that we have like glimpses of things that we can connect to, but we don't necessarily have the full picture. Like for example, we have like a store ID, we have first name, last name, and the email, which is good data. But then like our address ID is just a number. It's not meaningful. So what we want to do is we want to connect to the address. And so like if we take a look at what's an address, and that's what one of the things I like about SQL is, I mean, although it may be a little bit non-intuitive as far as like how we think about it, if we learn the words that we use in SQL to connect it to how we do things in real life, they end up being very much in sync with each other, which is what I really like. So if we take a look, you'll notice that address has all this stuff, and we have a list of addresses. And the way that we know which address goes to which customer is this address ID. Now, inside the address table, it's a primary key, and inside the customer table, it's a foreign key. And really, that's the only time in relational databases, if you're designing right, the only duplicate data we should have across all of our data is foreign keys. So like in this case, the only time we have the same address ID that means the same thing is in customer, or wherever we kind of reference these addresses. We could reference them multiple places, but we essentially do that so that way we have a single storage container that's built to hold addresses. And so that way, if we change one address, we change it for everybody who's attached. Maybe our little business here does family deals, like where we don't care if it's the parent or if it's the senior in high school or your college student that's home for the summer. They can all have an account under your one kind of customer. They are all customers under the same kind of account, so to speak. But they all live in the same address, or maybe they live at different addresses, that kind of thing. So essentially, we want to connect these. And how we do that is we use a join. So what I'm going to do is I'm going to start at the very kind of foundation of a join. Now, you'll hear throughout, some of it might mention it in the book, there's kind of two different standards for SQL. There's the Ansi 89 syntax, and then there's the Ansi 92 syntax. And basically, these were years that they came out with like a standardized kind of syntax for SQL, because I know we've had this conversation before, but we're using MySQL, but there's also Oracle, there's also Microsoft SQL Server, there's Postgres, there's MariaDB, there's Amazon's version, and they're all kind of have their own version of these databases, but they all use SQL. which is handy for us because we can only we can learn one language and kind of get them all, and it's easy to convert between the two. I mean, there's subtle differences when you get into more advanced things, but as far as the basics about joins, they all use the same kind of logic. So, but before, way back when SQL kind of first came out, and they said, hey, let's build a standard around how we do things. Obviously we weren't as sophisticated or knowledgeable about it as we became to be as things got iterated upon and became better. So what I like about this, though, is it shows us what the database is doing in the back end, and to me, it makes complete logical sense. And I think it's very handy. So essentially the old version, we're going to do this long form. So the long form method is by just a simple join, meaning we just join everything up. So like if, for example, if I want to just connect everything from customer, and we're going to give it an alias, so C. And when I do this, the C just means like, hey, so instead of typing customer every time I want to say what table it comes from, I'm just going to use C. But basically it's just denotes, like if we wanted to get like the customer ID, instead of doing customer.customer ID, we can just say c.customer ID. And we haven't used aliases before because we've never had more than one table. But now that we have more than one table, if two tables have the same column name, it's going to, throw a fit because it doesn't know which one, where do we want to get it from? So essentially we use aliases to let us know, hey, where do we want to get our data from? In this case, we're going to get everything. So, but we'll do some iterations on this. So we're getting our data from customer C initially, and we want to join that with address. And I'm just going to call that A. And from here, I'm actually just going to leave it this simple. So we're just going to connect everything. Now we'll notice that if we take a look at this, and let's order by c.customer ID. So if we take a look at this, you can see that our customer has been duplicated. We have Mary Smith in here a bunch. And in fact, we actually have Mary Smith in here for every address. See, this is her address from customer. In fact, let's clean this up so it's a little bit easier to read. We want the customer ID from customer. We want the C dot first name, C dot last name, C dot email, and then we want A dot address ID or C dot address ID. So this is the address ID from customer, and then A dot address ID. And the end result is we want these two to match, because that's how we're kind of matching these up. But if we run this, you'll notice that they don't. We have address 5 from customer. We have Mary Smith a bunch of times. And in fact, she's there for every address. In fact, if we sort this by both of these, we will end up seeing that she actually has been joined with every address. Now, that's not helpful for this exercise, but that can be helpful for other exercises. But for right now, the important thing to remember is that by default, a plain join is, if we don't tell it what to do, it's going to simply match everything. It's going to multiply the two tables. And I always like to think about dice. If we had two dices and I did a join between the two dices, we're going to get every possible combination of rolls if we were to roll two dice. 1 1 1 2 1 3 1 4 1 5 1 6 2 1 2 2 2 3 2 4 2 5 2 6, etc. You get the picture. So essentially we're getting, and that's what's called the Cartesian product. And you'll see that kind of referenced, like, for example, in our here, you'll see learn how to perform a cross join to get the Cartesian product. That's what we just did. We just did it with the old school kind of method where we don't really say specifically what we're doing. We just tell it what to do. But let's say that we want to, so now that we have every possible combination, if we want to get the ones that match, we just have to tell the database to filter out the non-matches. So what we can do is we can just say where C.address ID is equal to a.address ID. And technically, in this case, we're filtering in data, if that makes sense, because we're saying, hey, look, you have to meet these conditions to display, rather than we're looking for the exclusions. But now, if we do this, we've essentially matched one-to-one. So we came out with a bunch of records. In fact, we had 1,000 rows before, and it would be more, but it stops at 1,000. So technically more, but we had a bunch of rows, and now we're down to just 600, because now we have every one of our customers listed one time for their specific address, which is the desired effect we wanted. So essentially, when we do a join, we have to tell the database which columns, like, do I match these on, right? And in this case, it's mostly one-to-one. Our data is one-to-one. Now it could be one-to-many, in which case we would end up having more data. So, like, for example, if we went from customer to payments, which we'll do here in a little bit, we're going to end up with duplicates for every customer, because it's going to match the customer to every one of their payments. So when you're thinking about how is this join going to work, we have to think about, well, what's the relationship between the tables? And that's why those one-to-many, one-to-one, many-to-many, those kinds of things matters, because when we're doing these joins, we want to anticipate the outcome. But anyways, so this is ANSI 89 syntax for what we would consider to be an inner join. Now let's do the ANSI 92 syntax. So we're going to just take, and I'm actually going to take and just start with our same base here, get the same data. But let's add some stuff. Let's add our a dot, what is an address? Select everything from address. We have address and district. So let's just start with that. From customer C. Now this time what we're going to do is we're going to inner join address A. But in this case, if we're using the ANSI 92 syntax, we need to tell it here what we want to match on. So in this case, I'm going to say on. And essentially, this is like the where clause of the join. Like, what do I want to match on? Tell me how to match up these rows. Like, if I'm looking at address ID 5, what do I assign that to in the customer table? Well, we have this nice little thing where the two columns names match, the primary foreign key, and that's what we want to match on. It's pre-built, so we can just say on c.customer ID, or sorry, c.address ID is equal to a.address ID. So just like we did before, but this time it's in the on clause. And let's add our order by in here again, so we make sure our output looks the same. And there we go. So you'll notice that this one doesn't have a where clause. It just has the on clause, but the result is actually the exact same. Now let's do a theoretical. Actually, let's jump to, let me make sure. Does that make sense to everybody so far? Is there anyone who's lost?
I'm just curious, what would happen if you wrote where instead of on? Would it still work?
Yes. No. So because it's an inner join, so good question. Because this is an inner join, it is expecting an on clause. So if I were to run this, it's going to tell me, I actually know that works. Apparently MySQL, that works. Let me make sure. Okay, MySQL might be a little bit smarter than some of the others because it's anticipating it. Most of the time, this would expect an on clause. It'd say, hey, you're doing an inner join, you need to have an on clause. But in this case, it looks like it's kind of inferring that that's what you mean. So good question. I've actually never tried that because I know in Oracle and SQL Server, this does not work. But it looks like in MySQL it does. So essentially the same effect, just a little bit different.
Cool, thank you.
Yep. But really we typically use the on clause. And I'll tell you why. As we get going, you'll find basically what the kind of general rule of thumb is, because we're going to end up doing a lot of things here. And so typically you want to take care of your join before you ever get to a where clause. And we're going to talk about that because we are going to layer on some more joins. So for example, in this case, if we want the city, we need to do another join. So we'd say inner join to city. Well, let's just call it CTY, or we can leave it blank. And let's just say on a dot city ID is equal to city dot city ID. And there's that. So now the problem is if I were to change this to a where clause, you'll notice that now it breaks. So that's kind of like where that comes from. So like I said, it's kind of funny that it even lets you do that to begin with, which surprised me. But the reason why we probably wouldn't is because really these joins kind of work like this. So our first join was just like how we did it. And I like to think about it like we're gluing records together. So you can imagine if let's say we had cutouts of all of our records, basically, and we're laying them on a desk, we're just matching them up one by one horizontally. So that's kind of how I like to think about it. Joins glue records together horizontally. We're adding columns. So we're adding data sideways horizontally. And the way we do that is we layer on column on column on column. So in this case, we started with customer, single table, and we added columns from address. Then we take the result set of that. This kind of functions as a single table now. And then we join that against city. And then we add the city column, and so on and so forth. And now that we have that, we have our total result set. So like if the boss comes to you and says, hey, I want everybody's email, name, and address, bam, we have that. But let's say they say, hey, I only want this for people where the store is 2 or whatever that is. Then we could say, where c dot store ID is equal to 2. And then we could do that. And then he says, oh, well, I only want it where they're equal to 1. Okay, we got that too. So to me, I kind of like to think about it like, let me build my data set. And then I can use the where clause. After the data set's all put together, I have all the columns I need. I can use the where clause to get the result set that I'm looking for. Because a lot of times we'll use joins to build the overall result set. And then the where clause might be something we change depending on the report, but the overall result sets, the overall data set's the same. And we'll talk about that at the end of this course when we get to views. But for now, we'll just leave it at that. Good question. But anyways, that's an inner join. And so let's actually shift gears just a little bit because I want to talk about really what happens when and I believe it's, when we have sets and we different types of joins. So if you Google SQL joins, there's a great little Venn diagram. Do an image search for SQL joins, and there's this amazing Venn diagram that looks like this. And this thing is like my bread and butter. I love it because it talks about it's an easy way to visualize all of the different joins in a way that to me is very clear. And it may not seem that way at first, but like when I was learning joins, and even to this day, if I'm trying to think about what is the result of this going to be, oftentimes I'll just real quick, either just mentally or I'll actually draw it out, say, oh, this is what's happening. So I can kind of get an idea. So the join we just did is this middle one. And it's kind of, I wouldn't say the most basic, but most of the time depending on what our outcome is, if we only want to see, so in this case, like if we only want to see people who have an address, we use this one because in this case, customer is table A and address is table B. And you'll notice that in this case, we're only getting it where they intersect, meaning that if I have a customer who doesn't have an address in the system, they're not going to show in the result set. Does that make sense to everyone? This kind of Venn diagram as far as how that works, why they would be excluded?
Yeah, that makes
Okay,
sense to me.
perfect. Um, so that one is going to only include matches. And you can, from that explanation, we can kind of look at some of these others and make some inferences. So like in this case, on a left join, which we'll practice a left join here in just a minute, it'll get all the customers, whether or not they have an address. So the left join between either inner or left join, those two are by far the most commonly used joins. I use left joins a lot because a lot of times, you might add data and for a report, but that doesn't mean that they necessarily have the data. Like, so for example, let's say we're pulling all of our customers and we want to see which ones um, might, we want to see all of our customers, but we also want to see, oh, out of all of our customers, which ones are the ones that um, have had a late fee. You know what I mean? So we want to include all the customers, but we also want to add this late fee component to it. And that's when you would use a left join, because not everyone will have a late fee or, that kind of thing. Or for example, with a lot of our systems now, we collect like email and phone number. Maybe they have an email address, but not a phone number, and so forth. So if you had like an email table and a phone table, you would want a left join to those because they might have one and not the other. Okay, so let's actually play off that. And let's see if we have any customers who don't have an address. So this is actually kind of handy. So we're going to take this same kind of thing here. We're just going to actually take and cheat and just take this one. So we're just going to keep it simple. We're just going to have the address and customer data. But what I'm going to do is, instead of having an inner join here, I'm going to change this to a left join. And so we're going to have all the customers, whether or not they have an address. Now you'll notice that we still get 600 rows. So odds are we might not have one, but we might add one here to try it. But in this case, we're getting the same result set. But if we want to strictly see if we can find people who don't have an address, we can use our handy dandy cheat sheet here to kind of get the thing. And basically all we have to do is add a where clause to say where the other side is empty. Because now that we have all the results, we can just say where a.address ID is null. Because if they don't have an address, this will be empty. They won't have one. So we can do that, and we can see that there's no one here. So let's do this real quick. Let's hurry and add somebody. So I'm going to go to customer, and let's do generate SQL and an insert statement. So I'm just going to real quick insert one here. Let's get rid of some of this because I don't want to worry about that. So we're just going to do one. Bilbo. Baggins. Bilbo at lotr.com. I'm going to leave this null. On address ID. Active is 1. Create date is third date. And last update date is current timestamp. All right, so let's see if this works. Address ID cannot be null. Okay. So that one won't work necessarily unless we turn that off. Let's try this. Well, if it can't be null, yeah, let's just turn that off. And how do I do that? MySQL. Set foreign checks. Typically, we wouldn't want to do this, but we're going to do it right now. Where did I mess up here? There it is. Here we okay, let's set it to, if it can't be null, we'll just set it to 9999. Huh. Maybe I need to, there it goes. Okay. So now if we were to run this one, so now that we kind of put that in there, we have a customer that does not have an address ID. You can see now that we're just pulling him with that query because he's the only one where the address ID is null. So the left join can be really handy, not only for making sure we include all of the people, but also it can be helpful for finding people that are missing some information that maybe we require. But now if we were to pull this, we can actually scroll clear down here to the bottom, and we'll actually see, since we're using a left join, we have everyone else as well as Bilbo, but you'll notice that his address information is just empty, which may be desired, may be not desired. And that's why we need to make sure that we have the right data we are looking for. So let's go ahead and turn those back on. All right. That was a left join. Right join is the same thing, just the other side. And so really left join and right join are the same thing. It's all about just ordering on what you put first. So if I were to have address first instead of customer, you would do a right join instead. So it's just purely the order, because like if we were to put this on the same line, really what we're reading is everything on the left of literally where it says left join. So this is the left, this is the right. Everyone following okay?
Yes.
Okay, perfect. Okay, so what I thought we could do now, because that's kind of like, I think a good little basis. What I thought we could do now is go over some of the exercises. So let me pull this up over here. All right, so this one's just fill in the blank, I think, and we pretty much just did that one, so I'm not going to do that one. All right, so this one says write a query that returns the title of every film in which an actor with the first name John appeared. And this one's kind of fun because this one, the way that our model is, we have the film table. We have an actor table. But because an actor can be in multiple films and a film can have multiple actors, in the middle, we have this little table called film actor. And film actor, literally all it does is it just says, oh, this actor was in this film. This actor was in this film. And you can see that, you know, actor one has been in quite a few films. So if we want to connect films to the actor, we kind of have to go through this film actor table. And I like to kind of think about it like, you know, those like connect the dot puzzles, where we kind of have to like say, well, how can I get to this? Like I have to follow the chain. So that's what we're going to do. So let's select f.title, film.title from film F. And now I'm going to include everything here. So I'm just going to left join, and I'm going to go from there to film actor. We're going to call that FA on f.film ID is equal to fa.film ID. And how do I know where to match them on? Well, most of the time I just pull open the tables and look for the common denominator. Now, most of the time the column names should be the same or intuitive, but if they're not, sometimes you actually have to look at the data itself and say, hey, you know what are the two pieces here that I want to match together? Because sometimes they're not named the same. So we go there, and then from there, we have actor ID. So by going from film to film actor, now all of a sudden we have a path through the film ID to get into actor. So we just want to make sure those two actors ID match. So at this point, we're going to get all of our films. And if we wanted to add in our actor information, now we have the film and every actor that's been in it. So for Academy Dinosaur, it had quite a few actors in it, including like all these funny names that are half based on real people. But the instructions specifically say we are looking for someone where they have a first name of John. We want all the title of every film where the first name is John. So this is where we add a where clause. We want to filter out everyone whose first name is not John. So we're going to say where first name, or filter in rather, is equal to John. And there we go. We can kind of check this, and John Suvari looks like he's the only one, but he has been in quite a few movies. So at this point, we could just leave it like this if we wanted. Any questions on that one?
Why does that work without having to say it's from the actor table that we're getting the first name?
So good question, because normally I do put this here, but because out of all of the tables in the query, actor is the only one that has a first name column. So the system just assumes because it's the only one. Now, if I were to like add customer to this, there would be two first names. And at that point, it would actually throw an error. So just to kind of simulate that, I'm going to just cross join, which doesn't make any sense, but we're going to do it just for the sake of, science. Now, if I were to add this, it's going to throw an error, and it says that the column is going to be ambiguous, meaning that, column first name and where clause is ambiguous, meaning that, hey, there's two of these. I don't know where you want to get it from. So at that point, I could say a dot first name. Then it knows, hey, you're pulling, since there's two first name columns total in the data set, now you're pulling it from actor, and now we have it, albeit duplicated a tons of times because we cross-joined it against every customer. Good question, though. Normally, I don't. I always use aliases, but sometimes when I get talking, I just forget. But led to a good outcome. Okay. Question 3. All right, and this one has confused some people, and I think the larger reason why is because it doesn't make any sense as to why we would want to do this, but nevertheless, you never know. I mean, I've done weird things too on purpose, so maybe there is like a reason. Maybe they're matching up Secret Santa. Actually, that's a great idea. We're matching up Secret Santas for our customers, right? So basically what we're doing is we want all the addresses in the same city matched up with every other address in the city. So for example, if there's 10 addresses, we want every possible combination except the ones where they're the same, because you can't be Secret Santa for yourself. So essentially it's like not only are we doing Secret Santa, everybody's going to give a gift to everybody in the same city. Is basically what we're simulating here. And the reason why this is interesting and different, and I think why it stumps some people, is because it's a self join. because we want every address connected with every address in the same city. So like I said, most of the time we're doing joins on primary and foreign key combinations like this, where it's pretty clear, cut and dry. Hey, these two tables have the same column name. I'm assuming they match up, and yes, they do. Okay, great. But there's times when we need to join on things that necessarily aren't predefined. Like in this case, where we want to say, hey, we just want the places in the same city. So in this case, we're going to say, I want a dot address. Let's just start with the beginning. The way I like to do my joins is always just, because like I said, it's like layering it on. So I always just start with the base. So we're going to pull the first one from address. And I'm just going to call this A1, address 1. Right? Pretty simple. There we go. But what we want to do is we want to add city to this. So we're only going to care about ones that have a match. So I'm going to join city to this, and I'm going to call it C1. A1.city ID is equal to C1.city ID. Here's our results. We just want to add the city. Okay, so here's all of our addresses, and we can see the cities here. So what we want to do is, like, for example, for every address in Akua, we want to see, multiple rows where St. Denis Parkway is matched with every other address in there. So what we need to do is we need to and in this case, we're going to do let's do a left join, because we want to see those cities or the addresses who might not have a match, because we don't want anyone left out. We want to just be aware of those. So we're going to do a left join. So we have all of our addresses in their cities, and now we're going to try to pair them up with everybody else. So we're going to left join that, and this is where it gets a little weird, back against address. We're going to call this one A2. Basically, it's like taking the exact same copy of address and joining it against itself. But instead of, if we just did address ID is equal to address ID, we just get a one-to-one match. But in this case, what we want to do is we want to say on A1.city ID is equal to A2.city ID. Now, these aren't necessarily, these are both foreign keys. In both A1 and A2, these are both foreign keys. But they reference the same original data. So when we match these up, all of a sudden, hey, we have all the addresses that are in the same city. So now if I run this, we can, we need to add our columns up here. So let's add A2.address. And just for verification, we're going to add A2.city. And not A2.city, sorry. We are just going to leave it like that because we don't have an A2 city. So let's just do this, and looky here. You'll notice that we have this and it's matching up with itself. In fact, right now they're all kind of matching up with itself. And that's what we want to avoid. And there's probably more, it's just the way we're sorting them. So in fact, let's order it like this. Let's say order by address A1. Actually, let's sort it by city first. C1.city. A1.address ID. So now we're going to see it by city, and you'll notice a lot of these only have the one. Let's see if there's any. Here's some that have two. So you'll notice in Aurora, we have 587 Benguela Manor, and then we have Vilnius Manor. Now you'll notice that in this case, they're being matched up to themselves. Here's the one where they're different. Here's the one where they're different. And here's the one where it's matched up with itself. So we just want to now exclude the ones that are the same. And so we can do that. We could do this in two different places. We can use this in a where clause. We could say, where, but we can also make this part of our join. Now, when do we decide which? Like I said, if it's part of your join logic, I always include it in the join itself. So that way the where clause is available, or we can layer on additional joins like we'll do here in a minute. So what I like to do is I like to say basically we're going to add a condition to say, hey, we want these to match where they have the same city, but we don't want to match them if they're the same address. So where A1 dot address ID does not equal A2 dot address ID. So when it's doing the matching, it's going to check this logic. So, you know, back to our Aurora, it's going to say, hey, is 587 Bangwilla Manor city Aurora? This address has city ID Aurora. Does this address have city ID Aurora? True. Okay, it's in, but that's what we were doing before, right? And same thing throughout all 4 of those records. But now it's going to check an additional piece of logic before it matches it. So now it's going to look and it's going to say, hey, 587 Bangor Manor is in Aurora. This address is in Aurora. Match them, but we also need to check, is this address ID the same as this address ID? Yes. Okay, we don't want to include that because it says does not equal. So throw that out. So we're going to throw those out, and it's going to do that for every record it tests. So now if we were to do this and take a look at Aurora, you'll notice that we have our 2 records where they're different. So Bangwilla Manor is tied up with Vilnius, and Vilnius is tied up with Bangwilla. So now all of a sudden, like if we're doing like a gift exchange or something, we can see, you know, which 2 people essentially live in the same city, which is kind of cool. Now for the exercise, we did a left join here. For the exercise, I think they only want the matches, which should be 8 rows in total. So here's all of the people who live in the same city. So we just switch that left join to an inner join. That way we exclude all the non-matches. So all the people who don't have someone living in their same city, and bam, there we go. Does that make sense, everybody? Any questions on that?
Can you run distinct on that so you don't get those, like the top 2 are just the same one but switched in order?
Well, so distinct is actually going to keep the same result set, because distinct, did I put that in there? Select.
I think you're right. I think it does go there.
Let's see. Oh, so the distinct is throwing a fit because I don't have address ID in there. Go. Oh,
We need a comma.
there we go. Bam. So we're going to end up with the same result set, because even though they're like, you know, to us, we're matching the same addresses, the actual data itself, they're unique records. And just to kind of iterate this, you know, because we kind of just see 2 addresses, but like, let's say I want to, as so even though like distinct is only going to exclude duplicates, like true duplicates, meaning like if we actually had like Bangor Manor, Aurora, Vilnius Manor, this same exact record multiple times, then it would exclude it. But in this case, like we're kind of looking at 2 different things. So like, let's say we were looking, because like this is a movie rental store, right? So I'm trying to think of an example that would make sense. But like, let's say that is part of our movie rental store, we did like you opt in and you do like movie swap like requests. So like, let's say that I own the movie, you know, D2 The Mighty Ducks, and it's an old retro movie, hard to find, and someone says, hey, you know, I'm looking for D2 the Mighty Ducks. We might build a system where they can request like, hey, I'm going to throw out this request to everybody in my city to see if anyone has that movie. And in this case, like depending on the perspective, you know, it's going to change things. Or maybe we're sending out a mailer to let them know, like, hey, these are the other people in your area, so to speak. Like maybe we're dealing with like a homeowners association, and hey, everybody, this is everyone else who lives in your neighborhood and their address for an address book, right? And in that case, we use this data set in this way where we say like, this is like our route where, you know, like let's say I live at 587 Benguela Manor. I'm going to get one card that says, hey, you know, your neighbor is 43 Vilnius Manor, but they're going to get one. So like if I'm the homeowners association, the way I read this is, hey, these are all the addresses I need to send a letter to. And inside the letter, this is the address that I'm going to let them know exists. Like if we're putting together an address book, and technically we could join customer to this and it would make a little bit more sense. But the reason why we have multiple in here is because they are actually different records, if that makes sense. Like they're not duplicative. They are in fact different, because we're referencing two different things, so to speak. Does that make sense?
Yes, that makes sense.
So yeah, and distinct will only filter out like actual duplicates. So it's not smart enough to know that, hey, you know, these are mirrored records of each other. It will only find distinct duplicate records to filter out. But good question. Good question. Okay, that's that one. Question 4 is pretty easy. That's almost the same thing. It just has a where clause on it. So we're going to skip over that one. Okay, so this one is going to, this one's kind of more of like an exercise, like looking into the future. So on this one, we're actually starting to dabble in aggregation. And it's funny. I remember back when I was first kind of like going to school, I remember like being really confused about aggregation. And for some reason, it just never occurred to me to like look up the definition. But basically, when we aggregate things, we're taking many things and condensing them into a smaller subset. And the way I like to think about it is we're taking many records and we're turning it into one. That's what aggregation is. So for example, in this case, we're looking for how many rentals each staff member has done. So like a good scenario for this one is, hey, we're going to give out award, you know, to when our staffers meet a certain like goal or like a certain milestone of like, hey, you've done 2,000 rentals. Congratulations. Here's a gift card to the movie store, you know, to go bowling or whatever. And so that's what we're going to do. So let's start off by just getting all of the rentals for all of our staff members. So if we take a look at rental, select everything from rental, you'll notice here we have, okay, here's all of our rentals. We have a staff ID. Great. So this makes it pretty simple. We can just select everything from staff to kind of start our base. And if we want to make it match, we'll just get the first name, last name. Let's call this S. So here's our base. And now we're going to join that with all their rentals. Now, in this case, we want to get all of the staff members, whether or not they've had a rental, just in case. And this is where the type of join you use depends on what you want the end result to be. Like, what's your use case? In this case, we want to see performance amongst all the staff members. So we want all the staff members, even if they have 0, because really what it comes down to is, do you want to see those people who don't have any? If the answer is yes, you want to use a left join. In this case, I think we do. So we're going to left join to rental, call that R on s.staff ID. is equal to r dot staff ID. Now, in this case, we get a bunch of data, where you'll see we just have many rows, and that's because we joined the staff members to every rental they've done. So basically, we're seeing the staff side of the rental table. So what we want to do now is we want to take all these records and turn it into this nice little report that just says, here's how many rentals they each have. And we do that with aggregate functions. And these aggregate functions are going to condense those rows, but we have to tell it what we want to do. So the function is what we want it to do. So we've seen this in Excel where we do a sum, where we do average, a count, the same thing. So in this case, we're going to take a count of r dot rental ID. It's just going to count the number of records, and we're going to call that as total rentals. Now, if I were to run this, it's going to fail. And in the error, it says you're trying to do aggregation without a group by clause. And the group by clause is how we tell it, well, how do we want to do this? Because we have two staff members. Like, do you want to see, basically it doesn't know how to handle the data. Like, oh, you want to see the count of all the rentals, but like, do you want to see the count of all the rentals for like last name? Like, let's say we had Bilbo Baggins and Frodo Baggins, like it would be the same, or, basically we have to be more specific. So anytime you have a group by clause that has other columns, we have to tell it what we want to group by. And basically, general rule of thumb is you always just group by whatever comes before the aggregation. So in this case, we want to group it by the people's first names and last names. So I'm just going to say first s dot first name and s dot last name, because we want to see the counts for each staff member, for each first name, last name combination. So now if we do this, we get this nice little report, and you can see how, Mike Hillier had 8,040 records. And now we've condensed that down to one and turned that 8,040 records into one line item that just counted them for us. And let's see what else is in rental, because that's the exercise. Yeah, that's pretty much all there is in rental for us to do. Now, does that make sense to everybody what we just did?
Yeah,
Okay,
I
perfect.
think so.
So I'm going to take this one step further, just for the fun of it, because now we have all these rentals. There's also a table called payment. I'm in the business world, so I always like to tie back to money, essentially. So we have the rentals, and technically we could do this without going to rental, but if we want both stats, we can throw that in here. So what I'm going to do now is I'm going to also connect this to payment, and we're just going to do that on r dot rental ID is equal to p dot rental ID. Now this should connect the same staff members, but just to be safe, I'm going to do this as well because we have it there. So, and s dot staff ID is equal to p dot staff ID. And now, so we have our total rentals, but now what I want is I want to see how much money each person made. So I'm also going to get the payment amount as total revenue. And so now we can also see how many rentals for a total number of revenue. And if we really want to make this a nice report that is meaningful, we can do this kind of cool stuff where we say, hey, what was the average rental? Well, let's just take the sum of amount over the total number of rentals as average rental revenue. And so now we have some interesting data where we can see, okay, they have close to the same amount of rentals. John Stevens actually has a little less, but he has more revenue and his average rental is actually just a tad higher. I mean, nothing super meaningful. It could just be purely coincidental, but now we have some meaningful stats to say like, oh, is there something John's doing that makes more people want to, maybe they each run different stores. And so at this point we could say, hey, is there something John's doing in his store that's making people rent the more recent movies? If you, I don't know if you guys can remember like the old movie rental days, but they put the new releases out in the front because they got more money for those. So anyways, it's just some interesting stuff, but we will talk more about aggregation in upcoming weeks. In fact, it might even be next week. And that's when it really starts to get fun. But before we could get to that point, we had to cover joins. But anyways, we're at the hour mark. Does anyone have any questions before we hang our hats up for the day?
I think the only question I have is with regards to the final project and like ideas about what we could do there.
Perfect. Yeah. So feel free to jump off if you want, but and thanks for being here. But yeah, let's talk final projects for a minute. You're just like ideas, like some possible ideas. Is that kind of what you're thinking?
Yeah.
Okay.
So I'm just trying to think of something to, I guess, categorize or make a database out of that would have enough tables. Like one idea I had was just like a database of military aircraft because I'm interested in those.
Yeah, for
like
sure. Let's run with that one. You know what I'm gonna pull up? And actually, let's just do it this way. So I'm just gonna do file, new model, add a diagram. Okay, so military aircraft. So this one's actually kind of fun because I'm a little bit into aviation myself. So, but we can make this work. You'd actually be surprised how easy it is to get your 10 tables when we start to bust it all out. So let's start off with kind of the basis. And to me, the basis is an actual aircraft. So I'm going to have an aircraft table. And this is kind of going to be our base one here. And I'm going to kind of move fast just so we can kind of get through it. But aircraft ID. And, that's going to have basic information about the aircraft. Like let's call it base model name, etc. Because as we know, like various aircraft kind of go through iterations or etc. So what we can do is we can build like quite the kind of lineage, I guess, of aircraft, which is kind of what I'm thinking. So what we can do here is we have our aircraft. Let's start with I'm just going to kind of go through basics here. We have a manufacturer, which I think is pretty self-explanatory. Manufacturer ID, primary key, auto increment. So like in this case, aircraft would technically have manufacturer ID. And I'm just going to start throwing some stuff in here just so we can move fast. Foreign key, just to kind of iterate how this would work. Manufacturer, man ID. Bam. So I might not draw all the lines, but just throwing out some table ideas. So we have a manufacturer. Manufacturers make aircraft. Maybe each aircraft has, in a couple ways to think about this. We could have the aircraft be each specific version, or we could have the aircraft and we can wordsmith table names, but maybe there's like a series. In fact, let's just do this. Let's just have a model series. That way each aircraft is kind of its own thing. We have a model series. We have manufacturer model series. Let's say lots of different.
You could do country of origin.
Yep. Yep. So we can have like country table. Yep, that'll work perfect. Oh, I just renamed that one. Model series.
What about
Country
use,
table.
like commercial versus, I don't know, wartime or something?
Yes, and so I was actually just thinking a cool one is we could have like features or I don't know the word for this, but like skills kind of. I'm gonna call it skills because that makes sense. Where basically you can assign certain skills to certain aircraft. So this is the one I'm gonna actually model out here so it makes sense. So this one I'm gonna call it a skill ID, primary key auto increment. And we're just gonna give it a name. And then and just to show you how easy it is to kind of like add tables for every skill, I'm going to have a skill category. And that's where that like wartime kind of stuff will sit. So basically, like, is it transportation? Is it or transport, depending on like, so what I'm thinking is like the category is like more broad in the sense of like, oh, is this a skill category for commercial transport? Is it for wartime? Is it for utility? Is it for exploration, scouting, that kind of stuff. And then the skill would be something more of like, passenger count, yada yada, like, or passenger transport, freight transport, weapons, agility, and those kinds of things. So it's possible that an airplane, just like our film actor table, an airplane could have multiple skills, and skills can, every airplane is going to have skills, hopefully. And so basically we can have an aircraft skill table. And I'm just shortening this up. This is not best practice, but so we have an aircraft ID, which is an int. And then we have a skill ID, which is an int. And this one's going to connect to aircraft. This one's going to connect to skill. There we go. So now we can, and I guess instead of skill, we could call this a feature, I guess, or, whatever. But this would be interesting because then like for example, if I'm looking for all the aircraft that are good for, passenger transport, I could say, oh, like if I'm envisioning a website where I can like click a checkbox next to a skill, like, because maybe I'm looking for all of the aircraft that are good for passenger transport and they're very comfortable. I check both those, or I'm looking for passenger transport that's very reliable. Reliability could be a skill, or passenger transport speed and reliability. You can see how you can mix these skills, and once you say like, oh, I want all the aircraft where aircraft skill is in this, and this, and then bam, there's 3 aircraft these are the aircraft I want to fly on because they're fast, they're comfortable, and they're good for, passenger transport. Does that make sense? 1, 2, 3, 4, 5, 6. So we're up to 6. And we can add a lot here. So we have manufacturer. I'm thinking we can have military, and I know they have like certain names, but like a military org, like, oh, like what military organizations use the aircraft, and then we can have a table that's because these little intermediate tables end up actually adding quite a bit, because like an F-16 might be used by both the Air Force and the Navy. So it would have 2 records in here, aircraft ID F-16, military org ID Air Force, aircraft ID F-16, military org Navy, or Marines, or whatever, and that sort of thing. So now we're up to 7, and we can add more. I'm not the biggest buff necessarily, and that's where hopefully that gives you enough to kind of get started on them.
Yeah, that does help. Thanks.
Yep. If you get stuck and you need a couple more, just let me know. I can always throw something together pretty easy. Because if we're building a system, like let's say that we're just stumped, like this is all we want to do as far as the aircraft portion, all we have to do is say, hey, I want to let users have a favorites list or multiple lists, and each one of those lists have multiple aircraft. Oh, and I just messed that up. So there we go. So there. Now we're at our 10. So pretty easy to do. So now this would allow users to sign up. They could say like, oh, this is my if I could buy an airplane list, this would be it. Or this is my coolest, my favorite military aircraft list, or so on and so forth. And then they can assign aircraft to those lists. Does that work? Answer the question. You don't have to use this, but hopefully it gives you some ideas.
Mm-hmm.
Great. Any other final project questions? I actually had a little survey set up, but there's only 4 of you, so I didn't send it out because I thought we can just talk like human beings. But does everyone feel pretty good about the final, like as far as like what's expected? Maybe not exactly, but enough that you feel like, oh, I can get started on my ERD until like we talk about it some more.
I do.
Perfect. As long as you have your good next steps and you're not stuck, that's great. Okay. Well, anyways, if there's nothing else, thanks for being here. Have a great week. If we don't talk, stay safe. Have a great week. If you need something, feel free to shoot me a note on Teams or any of the other communication methods, and we'll get back to you as soon as we can.
Thank you.
Yep. Thank you.